We now look at the JK flip-flop example that says that we sketch output from Q1 for the 5 clock periods, assuming that the both flip-flops are initially in 0-1 state. So this is 0 and this one is 1. Yeah, so we want to find the sequence of changes in Q1 for the first 5 clock cycles. And what we need to develop is the state table for this circuit. And the state tables requires us to have the clock pulse, CK. We are moving for the first 5 clock pulses, so 1, 2, and 5. And we are observing that we have 4 inputs. So this is J1, K1, and J2, and K2. And then we are asking ourselves what are the next states or the present state, which is Q1 and Q2. And what is the next state? Q1 plus 1, or Qn plus 1, can still call it Q2. So this will give us, this is the state table that we must always develop when we are analyzing a flip-flop. And some of the best way in which we can know how we are transitioning is by equating, knowing that J2 is being fed signal Q1. For that reason, you say this is equals to, this is J2 is equals to Q1, K2 is equals to Q2 bar, J1 is Q2, and K1 is Q1 bar. So when we know those equivalents, we can quickly be able to develop this table. And we are told that the initial state is 0, 1. So we know Q1 in the present state is 0, 1. So if we know those two, we can always be able to get J1 to be 1, K1 to be 0 bar, which is 1, J2 is 0, and K2 is Q2 bar, which is 0. And we know from the characteristic table of JK, I always write it somewhere for the sake of easier remembering. This is the characteristic table of the JK. Therefore, when we find that we have JK as 1, 1, we know the next state will be Q1 bar, which was 0 and therefore becomes 1. When we have 0, 0, we know it will remain as Q2. Since Q2 was 1, then we have a 1. And these two become here, 1 and 1. And we transfer them to where they are. So Q1, we bring it here. Q1 bar becomes 0, Q2 becomes 1, and Q2 bar becomes 0. Again, we ask ourselves, when we have 1, 0 from this table, we get a 1. So this is a 1, and the next one is a 1. So a 1 come here, and this repeats themselves, and this cycle repeats until the end. So that is what we find with this table. And what we can confirm is that that is what we have here. And what we are simply saying is that our next state is transitioning from being, we are observing Q1, so we are moving from 0. The next state becomes 1, 1, 1 to the very end. We have said this is going to be a 1, 1 because they are repeating themselves. And therefore, we move from 0 to 1, 1, 1 for 5 clock pulses. 1. Actually, this is the 4th one, this is the 5th one. Because this was the 0 clock pulse, 1, 2, 3, 4, 5. So if you are to draw a waveform for the first 5 clock pulses, the waveform would simply take this form, that it was initially 0 but became 1 for the rest of the clock pulses. So that is our solution for that problem. Another example says the flip-flops below are initially cleared. We have 2 flip-flops formed differently, and Q1 is initially 0 and Q2 is initially 1. We are to determine the output signals at Q1 and Q2 if the input signals are shown here. So we can see that this is the first, second, and 6th clock pulses, and the J is moving from 0, 0, 1, 1, 0, 1, and the K is moving from 0, 1, 1, 0, 1, 0. So those are the inputs that we are going to be feeding to our J1 and K1, and we can see that J2 is being fed from Q1 bar and K2 is being fed from Q1, and we are observing Q2 and Q1. So we are going to draw the same state table like we have drawn in the previous examples, and what we just need to know is that we always start with the clock pulse and moving from 0. We want the output signals, and therefore we can consider the 6 clock pulses that we are given. We start out with clock pulse 1, 2, 3, and to 6, and then we observe we have how many inputs: J1, K1, J2, and we have the present state as Q1 and Q2, and we have the next state as Q1 and Q2. So we again observe how these are related, and we can see that K2 is equals to Q1, write it there, and J2 is equals to Q1 bar, and K1 is given here. So J1 is 0, 0, 1, 1, 0, 1, that is our J1, and K1 is 0, 1, 1, 0, 1, 0. So having known those two, we know the initial state for Q1 is 0, so we say this is 0, and for Q2 is 1. So therefore we can be able to say J2 is equals to Q1 bar, which is 1, and K2 is equals to Q1, which is 0. So because we know the characteristic table of JK, we again redraw it here, and we say this is Qn 0, 1 and Qn bar. So if we find that we have 0, 0, the next state for Q will remain, which is 0, and 1, 0 will give us a 1 in the next state, as you can see here, and then this becomes our next state right here, and then we ask ourselves what is this becomes Q1, which is 0, and Q1 bar 1. So again 0, 1 will give us a 0 in the next state, and 1, 0 will give us a 1 in the next state. So we bring this one here, and then we know this becomes 0, this becomes 1. 1, 1 will give us opposite of what we had. So if we had 0, this becomes 1, and if for J2 we have 1, 0, the next state is a 1. We bring this 1, 1 here, and we say this is a 1, this is a 0, because it is Q1 bar, and then 1, 0 will give us a 1, and 0, 1 will give us a 0, 0, 1, 0 comes here, and this cycle continues. So we will move to the next point where it is developed. But even before we do that, we can just fill this to find that it is going to be 0, 0, 1. So this becomes our state table for this arrangement of flip-flops. And the question is now asking the output signal at Q1 and Q2. We can see that Q1 is transitioning from, it was initially at 0, and then formed all these, so it became 1, came 0, then 0 again, then 1, then 1, then 0, then 1. So this is how our Q1 is transitioning: 0, 0, 0, 1, 1, 0, 1. And for Q2 is moving from 1, 1, 1, 1, and then 0, 0, 1. So this becomes the transition for Q2, and this is the transitions or the output for Q1. You can give them together or individually depending on how you like, and you can always be able to draw the clock pulses for these changes, as we can see in the next, as we can see here below. So this is the table that we have developed. It is exactly as we have drawn it, and as we have seen that our Q is transitioning from 0 to follow this pattern 0, 0, 0, 1, 1, 0, 1, and Q2 is transitioning from 1, 1, 1, 1, 0, 1. We are able to see that that is represented by this waveform, that is for the first 3 clock pulses, our Q1 is at 0, 0, 0, 0, and for the next 2 it's at 1, 1, 1, and the next 2 clock pulses become 0 and 1. So what we observe here also is that, and that is very important, is that these flip-flops are negative edge triggered. You can see these are negative edge triggered. And therefore, as much as the inputs are not syncing with the changes in the clock pulses, what we observe, the outputs of the flip-flops are happening at the negative edge of our clock pulse. So as you can see, at the end of the third clock pulse, when we meet a 0, that is when the output is changing from being a 0 to a positive or to a 1. And then the next time it is transitioning is at the negative edge of our clock pulse. So be very careful with that. So we have seen that that is for the waveform for the Q1, and similarly for Q2, it is moving from 1, 1, 1, 1 for the 4 clock pulses. You can see this is 1, 1, 1, 1. And after the 4th clock pulse, that is when it transitions to 0, 0, and then goes back to 1 at this negative edge clock pulse.